Very brief overview of some noise stuff here. We talk about noise all the time. I want to point out that the red trace here is intended to show what truly raw data from the transducer looks like. Transducer data is loaded with all kinds of noise. And one of the other reasons for a filter is just to get rid of artifacts or resonances in the transducers themselves. So the raw data from the transducer, you pretty much don't see anymore these days because they plug into the DAS and the DAS filters a lot of that out. So your quote-unquote raw data has actually been hardware filtered. But then finally, when you apply the software filtering, that's when you see in the process data the final curve. So there's this kind of evolution of noise from a bunch of random junk or mechanical motion through to the data that's been digitized by the DAS, through to the data that's produced by the system. In the test lab, all test labs, just like we are now, are being washed over by electromagnetic energy from the lighting systems, from everything. It's very important that you understand that electrical noise can distort data and even affect injury measures. And so proper grounding and shielding techniques are extremely important. All the DAS systems are designed to reject environmental noise. But if you don't use the proper grounding and shielding techniques, then you're not getting the most benefit. A word about electrostatic discharge. If you are working with airbags, supplemental inflatable restraints, they generate enormous amounts of electrostatic discharge. If you've ever seen the thing about rubbing a balloon on your head, or you shuffle across the leather shoes on the right kind of carpet on a dry day, well, the airbags generate that kind of static. Remember that the transducers in the dummy or even in the seats are strain gauges bonded to metal. If I have electrostatic discharge to that surface, a little bit gets into the gauge, and ultimately, boy, that's an ESD spike that shows up in the neck load data. If I use proper grounding techniques, though, basically making sure I've got a ground wire running between all the various parts and pieces, electrostatic discharge bleeds right off to the ground, the sled body, the test fixture, whatever. It's very important. So I want to leave a couple more words about grounding and shielding. Here's some advice. If you work with test dummies, very important that all of them, what I call isolated metallic parts of the dummy, are grounded together with a nice fat wire. So if I've got a head, a torso, a leg that's got they've got transducers in them, the metal parts of those the dummy need to be tied together with a ground wire, and then in fact tied back to the DAS location. So graphically here, if I've got a test dummy, I want to make sure I've got a good ground conductivity between the head and the torso and the pelvis and the legs, and then I've got a big fat ground wire that goes back to where my DAS is mounted. Can't say enough about the wonders that simple practices like this make in getting good data. Problem is, a lot of people don't know when they got bad data. So just do it right.